Welcome to another session of Ebenezer GATE coaching classes. This is a problem that appeared in GATE 2022. It is a numerical aptitude type problem for 2 marks. A circuit and the characteristic of a diode in it are shown. The ratio of the minimum to the maximum small signal voltage gain, dou V naught by dou win, V in this dash, rounded off to 2 decimal places. Now, we are given the characteristic equation of the diode. Now we can replace the diode if it is forward biased, then we can replace it by its cutoff voltage, which is 0.7 in this case. So if it is forward bias, it can be replaced by a battery of 0.7 volts. And if it is reverse bias, it is replaced by an open circuit. So let us find out what is V out when it is forward biased and what is V out when it is reverse biased. So when it is forward biased, then the circuit becomes 2 kilo ohm .7 volt and 2 kilo ohm. Since the circuit is forward biased, all the current flows in this direction and no current flows in this is 2.2 kilo ohm resistance. Because the forward bias diode will be acting as a short and no current will flow to the parallel 2 kilo ohm resistance. Now, in this case, this is V naught and this is Vn. So let us write the equation. Vn, let's assume that a current I flows here. So Vn is equal to I into 2 kilo ohm plus 0.7 volt plus I into 2 kilo ohm. In other words, I will be V in minus 0.7 by 4 kilo ohm or 4,000. So the voltage across the 2 kilo ohm resistance, this voltage, let's call it Vx. So Vx will be I times 2 kilo ohm. So this implies Vx will be 2000 into I, or it will be V in minus 0.7 by 2. Okay, so Vx is V in minus 0.7 by 2. And V naught will be Vx plus 0.7. V naught will be Vx plus 0.7, that is Vx by 2 minus 0.7 by 2 plus 0.7, or it is Vx by 2 plus 0.7 by 2. Now, sorry, Vx is V in by 2 minus 1. So, dou V naught by dou V in is 1 by 2. So this is the condition when it is forward bias. Now let us find out what happens if it is reverse bias. If it is reverse biased, then you have a 2 kilo ohm here, a 2 kilo ohm here. This will be open, and you will have a 2 kilo ohm. So this is V naught. Let's say this, let's call this I1. So this is V in. V in is equal to I1 times 2K plus 2K plus 2K, 6K. And V naught is I1 times 2K plus 2K, that is 4K. And V naught is equal to V. Suppose I divide both the equations, I get V naught by V in is 4K by 6K, that is 2 by 3, implies V naught is 2 by 3 V in. So when it is reverse bias, V naught is 2 by 3 V in, or dou V naught by dou V in is 2 by 3. So this is dou V by dou V naught by dou V in when it is reverse bias. And when it is forward bias, it is 1 by 2. So maximum value of dou V naught by dou V in is 2 by 3, and minimum value is when it is forward bias of dou V naught by dou V in is 1 by 2. So the ratio of minimum value by maximum value is 1 by 2 divided by 2 by 3, which is 3 by 4 equal to 0.75. The answer is 0.75. So the ratio of the minimum to the maximum small signal voltage being dou V naught by dou V in is 0.75. Thank you. God bless you.